So we are recording. So again, if you don't want to be included, feel free to keep your video off, stay muted, ask questions in the chat. And then we'll have some time at the end where I can stop the recording and have a little Q&A if you'd rather just talk. Okay. So again, I'm so grateful to Johanna for jumping in last minute to teach the class for us. For those who came in late, our original instructor had a family emergency and wasn't able to make it. So I will hand it to Johanna so that Johanna can introduce herself and share what she has to share. Let's see. All right. And so you should be able to share your presentation now, Johanna.
Perfect. Okay, if you cannot see it for any reason, please just holler. And then, yeah, I think Caitlin said before, but if you have questions, comments, concerns, or places where you're like, I think she might have messed up there, let me know. I'm open to any of it. But with that, Bujun Dinwe Magna, Bungi at the go, and Gikendan, and the Shinabe Moyan, Daga Bibika, and then a mission, Gishpin, Fornakijwayan, Joe Hanan Indigenous, Wigwasig and Dunjaba, Gigun and Dudem, Nagachuanang and Da, Diban Wade Ayan, Aman Nagum, Miigwech Prison Dalyeg, Ningum, with you. So, my name is Johanna. I go to Cloquet High School. I am a 9th grade student, and this is my science fair project. So my science fair project is a lot less standard than other people's science fair project because I worked really hard to bridge both Indigenous teachings and mainstream science and how both can work together collaboratively to be able to help one another in a way that doesn't ramrod over and take over any perspective. But my project is the disinfectant properties of yellow water lilies. So the plant in Ojibwe is Ojibwe bug. It's kind of one of the things I love about the Ojibwe language is how descriptive everything is. There is no just straight word for it. Most of the time you can figure out how the plant interacts with its surroundings, what it looks like, where it grows, just based off its name. And that was something that I really loved about this because it caught up to me in mainstream science. So it means colored leaf, like roughly translated. And that's how you identify it. And there's another plant that grows in our area, and it's very, very similar. In fact, genetically speaking, they are almost the same plant. But the only difference is that it has a colored leaf. So that was something that I loved learning as I went through, just because of how much our language plays a role in everything we work through. So the part that I used in my project is condush, or the rhizome or roots. So this plant grows on a tuber system, which means there's this root and it's like the size of a small tree, and it's like pretty hefty when you feel it in the water, and it connects all the plants on the lake. So every part that you see is connected somehow to the other yellow water lilies on the lake, and that's something that was really kind of fascinating to me as I did it. So because of just overall colonization and all sorts of factors, I had to bridge two different stories to get the harvest techniques, preparation, all those kind of techniques to be able to do the plant in a good way. So I had to learn the story from Ojibwe's teachers in Canada and throughout Minnesota and Wisconsin, along with the Menominee teachings. And you could see how much bridging had to go in when I get to my slide of all of the people who helped me, because it's never ending. And it's really kind of crazy how many people. So this plant in traditional stories is the only medicinal plant that we used. And when I started diving into the mainstream science aspect, I was catching a lot of this new Farlutia. Now, I had to use that name because it's also called yellow water lily, but new Farlutia doesn't grow here. It in fact grows in Europe. But some botanists had been saying that our yellow water lily here was really, really closely related to new Farlutia, and they were like cousins. And if that was the case, I'd be able to apply any research done to new Farlutia to the plant that we have here. So here's just some of the research that's been done. They've done antibacterial studies in Turkey. They've done antimicrobial studies in the UK and Israel, and then they actually have been using it in septic shock cases in Israel, and that was really interesting because that is not nowhere near our stories. It's used as a disinfectant and a GI cleanser and other there's a lot of properties that it's used for, and it's used for like a tonic in your mouth. But the main one is the disinfectant. So, with this and how they weren't aligning, I did a taxonomy review. So, what the heck is taxonomy? When I started this research, I had to do a ton of research. So, the taxonomy is the branch of science that's concerned with the classification of organisms. So, it it's that stuff we have to learn in school where it's like it goes the kingdom, the family, genus, species, that kind of stuff. But the whole thing is called the taxonomy, and I did the genus, so the one step up from species. So this is a morphology tree, which is just a fancy word for how things are related. But this is the one that was first done when Europeans first had contact with the Americas, and it puts the plant that we are know and have been taught about, Nuphar albina, right next to Nuphar lutea. Now, this is the one that grows in Europe. Now, in this morphology tree, it states that they're closely related, and if that was the case, I'd be able to apply all the studies. But I didn't really want to stop there because traditional stories didn't say that, and it didn't make sense to me why it was so different. So I kept digging. And in 1958, a scientist named Beale did this life-changing study where he separated the old world plants from the new world plants. Now, when I found this, I was like, duh, of course they're separate. That's over there and this is here. But it was life-changing at the time. And as I dug into science, you can see where it's life-changing, but it separates it. So there's new Farlutia right here, and there's new albina up here. And then in 2017, they did a phylogenetic tree, which instead of classifying things just off of looks, it classifies them based off of their genetic markings. This just pretty much separates them into their actual genetic family, kind of like a family tree. So it separates it even farther. So there's Nuphar albina right here and Nuphar lutea way the heck down here. So you can see how many branches it went through. They're like very distant cousins. So that means I had to repeat the study, which I kind of thought I was going to have to do at the time, but it was good for me to have that scientific backing. So I went ahead and I harvested it. I reached out to the DNR just so I'd have that base covered. But then I also reached out to Fauna Lac Research Management just to kind of get their take on it and make sure that there isn't any harvest regulations on the reservation, because lots of times we don't want large scale tampering with lakes just because that's probably a good practice. Maybe not tear up our waterways. So I reached out to them both, and they're like, yeah, if you're not taking more than 2 feet, you're good to go. So I went in and I took like not even a foot. It was a little over 6 inches. And I harvested it at Tamarack Lake because that was the lake that had the least amount of pollution in the areas I needed to be in. Pollution meaning like dropped lures. I'm sure there was just as much heavy metals, but I had to do this barefoot because traditionally As it's in the water, it's a women's medicine. So me and my mom were the ones working with it. And we got in the water, and I had to wade in the water and snap the roots off of the tubers with my toes, which it's a very hands-on project, in a way that I wasn't quite prepared for. Um, but it was really cool to have that I think we miss out in mainstream medicine, of that connection with our plants, of how they heal us and they feed us and all these, but I feel like we lose the connection as it's processed down and we go to Walgreens and we get it in a bottle, which is what I tested it against, is the most common disinfectant bottle that I could find. So I harvested it there. This slideshow I used in my science fair presentation. So there's a lot of like water temperature notes that really don't mean anything to anyone other than scientists who are like, so what was the water temperature? Sometimes I think they just try and nail you. So here's the rhizome once it's out of the water. And this picture right here was actually really life changing for my research, because you can see here that it absorbed sediments around it. So it's really porous and it's kind of like a sponge, where when you cut it and you pour water over it, the water goes straight through it. So it had absorbed the dirt and the grime from all around, and that made me question about what does that mean for all of the heavy metals that we have in our waterways right now, and how could that be getting into our bodies as we utilize it as a medicine. um, so that becomes the next question that I wasn't able to do this year, but I'm hoping to do in the following years. So this I kept it in because this was really cool for me, and I did science fair. I get to bring this to an international science fair, and I go to Georgia and I present it to all the Ivy League college scouts, and you can it's really exciting for me personally. I don't know if it's exciting for the community as a whole, but it's really exciting for me personally, because I gonna have all these crazy opportunities because of this. So um, I'll talk about this later, and I have slides describing this. But if different dilutions of Nufarabina, which is the yellow water lily rhizomes, are applied to Micrococcus luteus and Staphylococcus epidermis, which are bacterias, using the disdiffusion method, then the rhizome dilutions will have a measurable zone of inhibition, with the higher concentrations being the most effective. So I have two hypotheses, but this is the first one, and I would say probably the main one. Um, so I first did my research at the middle school lab, which I regret now, but it happened and we do it. So I went in and I worked with a teacher from the Cloquet Middle School, and she was trying to get me to change my project so that it would fit better in the science world. And if it's one thing my parents and my grandparents and all my family has raised me to do, is to be stubborn. That's not always helpful all the time, but I'm glad I was stubborn in this case, because she really wanted me to change it and take out the pieces of our stories and our teachings, and I wouldn't do it. I was too stubborn, but at the end of the day, it got me to where I am now. But part of that is I had to compromise just a little bit. So I wanted to do a straight powder plate. So traditionally, the powder was packed into your wound. So if you got a cut or a scraped, or you like tripped and your skin was like really hot, they would grind up the dried root and pack that powder into the wound as tight as you could get it. And I find out later on some more reasons for why that works so well, but in the time we didn't know what activated it, and I still don't. But is it the moisture from your blood and your skin that gets the root to just get going, or is it just like this all the time? But because of the test I had to do, I couldn't do powder because it was too dry, and the test itself has to have wet samples. So that's where the concentrations come in. So the 0.6%, 1.25%, 2.5%, 5, 10, 20, those are all amounts of water put in. So there was 0.6% of the rhizome put into however much water that was. I don't remember how many milligrams and stuff, but at 20%, it started getting really, really thick. So I had to stop making the concentrations at that point because it needed to be somewhat liquidy. And I dried it 3 different ways. I probably should have mentioned that before, but we'll mention it now. I dried it in the sun, in the shade, and then in a mechanical dryer. And that was because out of all of the research I've done bridging Menominee stories and Ojibwe stories, the one thing I couldn't find was how it was dried. I don't know why, but that was the one thing that we'd lost. So I just kind of threw them all at the wall and hope one stuck. So I did it in the sun because that seems like, yeah, that's a logical place that we could have dried it traditionally. But then I did it in the shade, sun and shade together because I didn't really necessarily know what activated it. So I wanted to do that. And then mechanical just for a control. So the bacteria I did in this one was Staphylococcus epidermis, which is just a normal skin bacteria. It's one of the major bacteria on our skin. And I did it in a streak method. So the bacteria came in a little vial and it was growing on agar, just the dry bacteria. So I put a cotton swab on it and then I put it all over the plates. But you can kind of see here. Yeah, you can see where I streaked it. Now, if there's any microbiologists or any scientist in the room, my etiquette on this, not up to par. It really isn't. So I ended up having to repeat it later on at UMD. But this is the graph of that research. So my chemical control was chlorhexidine, which is just a skin antiseptic. So here's chlorhexidine, how it compared. And in these boxes are the rhizome. So was crazy to me because of how well it did. This is something that has been boiled down in a lab, isolated the compound. It's been tested on for years and years. It's been like lab ratted this, you add a little bit of that. Maybe it's kind of like a witch's brew, honestly. A little bit of this, a little bit of that, mix it all together, and we'll see what happens. But this is something that we've had for way longer. We've had it and it's kept us alive, and you can see why. It works well. It kills the bacteria. So here's these rings. I feel like I should explain this a little bit. So here's the chemical control, and this had contamination actually. So there was a bacteria strain on it that the chlorhexidine couldn't kill, and that's what that white ring around that's filter paper. That's what I dipped my samples in. So there's a ring there, but this orange ring it's called the zone of inhibition, and that's the amount of bacteria that's been killed on the plate. So these orange rings represent how much bacteria was killed. And compared to this, they performed relatively well. And you can see how it cleared the bacteria strain in it as well. So there's that. And then here is me at UMD. And in this round, I used a different bacteria, and I also used a different agar, but that's a whole different ball of wax. That really doesn't apply to my study, but they wanted to know. So Micrococcus luteus is also a common skin bacteria, and it's just another one, but this one tends to be used more on medical research. So that's why I did this one. And at this point, I had to use my same samples. So at this point, I had different amounts. My 10%, my 20% concentrations were really, 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 really thick, and they weren't working. They weren't sticking. They weren't doing what they had to do. So I had to not use those ones, which was kind of sad because those high concentrations worked a little better. In this one, you can see the 20% was one of the highest ones. And in the sun, 10 and 20 was the highest one as well. But
Hey, Johanna.
Yeah.
I'm sorry to interrupt you. Can you do me a favor? I think I gave you the power to let people in from the waiting room. Would you
Yeah,
double
hold
check
on.
the
I
waiting room
gotta,
really quick? Sorry,
yeah,
everyone.
I have to,
1 second.
it's all good. I am on a Chromebook, my school Chromebook, and I can't have my PowerPoint going while I do this. So sorry
Okay.
about that.
Nice. Sorry, everyone. Maybe a stretch break or something. So it's my first class, so I must have clicked the wrong thing. All right.
Okay. I thought I accidentally kicked someone out. So if you saw that weird look on my face, it's because I almost kicked someone out. So if somebody got kicked out and now you're watching the recording, I'm really sorry. It wasn't on purpose.
And then are you able to make me co-host? So then I don't have to interrupt you again.
It doesn't want to let me. It says make host, but that's it.
Okay. Well, we'll just roll with it. Okay. Thank you for doing that.
Yeah, no, for sure.
Yeah, thanks everyone for your patience.
All right, let's get back into this. Oh wait, hold on. There's someone else. My out of my while I'm still here. Okay, there we go. All right. Well, there we go. We gotta let it do its thing. I have to also use my hotspot. So those of you who live on the res and you understand my struggles with internet, you should have seen me before this meeting trying to get in here. My internet wasn't working, so finally gave up, and now I'm using the hotspot off my phone, and now it's working. But this res internet sometimes is not it. So here's this. I think I talked about my concentrations. So here's this one. This one, I got to use a different kind of bacteria, which is kind of cool. I used liquid bacteria base. So the bacteria was suspended in, I'm not exactly sure what it was suspended in. I think it was some type of agar, like food for the bacteria, but I don't know. When I got it, it was liquid. So I had to spread it on a plate, and I got to use this circle thing right here. It's kind of like a lazy Susan. It's called a plate spinner, but you like spin it and it just keeps going and going and going. And you get to put your plate in there and you get to push around the liquid. I don't know. It reminded me of when I was little and I'd make the like mud pies and you got to swirl it all around just to make them nice and mixed, and then you shape them up. It's science is like, I don't know. It's kind of like being outside for little kids for me, because I get to go in and I get to play with all these crazy, kind of dangerous toys, but I get to play with them. It's fun. So this was my second hypothesis, and this was the different drying methods, because I wasn't sure. So this was how, if the Nuphard bean or rhizome is dried in different ways, then the sun drying method will have the greatest impact on Micrococcus luteus and Staphylococcus epidermis growth. So I also had those two different bacteria strains, and they performed really different for chlorhexidine. So here's the graph for this one. And chlorhexidine looks like it did way better in this one, and it did. Chlorhexidine did insanely better, but the rhizome and the root powder did relatively the same as it did before, but chlorhexidine killed the bacteria way differently, which is something that one of my judges in science fair pointed out to me is something that shouldn't happen, and that actually represents the resistance that we're developing to bacteria strains. So I'm not sure if everyone knows this, but part of why I did this research is because there's starting to be documented cases of when Western medicine isn't working on people because we've used it for so many years that our bodies are starting to develop a resistance to antibiotics like penicillin and amoxicillin, all the cillins. So especially the cillins. There's other ones too, but antibacterials and different common medications are the most common because we use them so much. So that's part of why I wanted to do this. So here's this graph, and it kind of skews the scientific, like how it performed a little bit, which is a little disappointing. But chlorhexidine, it did really well, but the rhizome did just as well as it did before. And it actually, the sun method is right up there with the line. You just can't see it because of how far away they are. So here's my really fancy scientific way of how I described everything the whole way through. Um, this one is saying that my first hypothesis is partially supported because I said that the sun drying method would have the greatest impact because I thought maybe that UV radiation would have an impact on how the rhizome performed, and it didn't. And this dehydrated method one is only from this study, which was a little disappointing when I did it, and I wish I would have done another graph from the other study because this is only this graph, and this graph really doesn't, you can see how much error there was. So these bars are supposed to take the average so you don't have as much error, but you can see how much error there was in it because it's not even possible for the dehydrated method to kill more than the chlorhexidine because chlorhexidine cleaned the plate. So how the rhizome killed more than the plate diameter is beyond me, but that's what the graph says. And so this graph is a little iffy, but it says that it does show that the dehydrated method did work the best, and comparatively it did work a little better in that one, but that's only because it was that study. So then my second hypothesis was also partially supported because the higher concentrations in the first round of it that I did at the middle school was the most effective, but when I did it again at UMD, it was like the midpoints that were most effective. So this 2.5% into the dehydrated did amazingly well, and then in the sun, 2.5% did really well too. So this part, I kind of been talking about this my whole presentation, but I can do my closing statements. I have them down at this point. So in this one, Meeker, that's the scientist who did some of the research on those taxonomy and morphology trees that I talked about earlier. But he recorded that Ojibwe people use the yellow water lily as an antiseptic, and that it just is the first time it's been recorded. I do not think that we had just started doing it when some European scientist showed up all of a sudden and was like, oh, this is cool. They do that. But that's this. I have to have that in there as why I did it. So it shows that the rhizomes that we've been told for thousands and thousands of years that have medicinal properties actually do have medicinal properties. And that's why I did this project to begin with. Is I wanted to be able to have scientific proof that what we've been taught for thousands of years has value and it is important. So I'm hoping that my project as a whole can set some form of a precedent of how we can go back and reclaim our old ways and introduce them into Western medicine on our terms to be able to keep us healthy for thousands of years more. Um, so this is the part that I was talking about a little before about pharmaceuticals. So they're becoming less effective, and we need new medications to come in and take the place of that. And by looking back at original uses of plants, we can create sustainable ways for developing pharmaceuticals in ways that benefit society as well as ecosystems. This, I don't know if you all know this picture, but this picture is something that when I found it, it was amazing. My mom found it for me actually. And this is an artwork by Christy Bellacourt. And I felt so cool to find it because I found the Indigenous artwork for the work that I'm doing and the plant that I'm studying. And it was something that was so cool to me because I feel like our artwork kind of voices our culture and our teachings a little more than words can put it into. And I actually made a ribbon skirt. I took that slide out. I made a ribbon skirt off of this artwork, and it has the appliques of all of the water lilies going up out of the water. I might actually go out and find it because I'm really proud of that skirt. So here's all the next questions that I have all together. So what activates the medicinal property of the root? The moisture from the wound and the skin, or is it some other factor? And then does the UV radiation from the sun impact the effectiveness of the yellow water lily rhizome? And do the rhizomes absorb heavy metals in the water around it? So here is that heck of a list that I was talking about. And I think there are actually more people now. But the thing about this list that just makes my heart happy is from here down is all the people with like really fancy PhDs and jobs at universities and all that. And these are all elders. And they probably should have PhDs with all the work they've done. But these are all the people who made it so that I could do this project. They kept it alive. They kept the stories, the teachings, um, the sheer spite of just saying you survived alive. And then here's all of my references, which there is this book right here. If there are any like budding ethnobotanists or microbiologists or ethnopharmacologists, any scientists of any type, if you want a perfect ethnobotany book, the Ethnobotany of the Ojibwe Indians by Glyphwick is my favorite one. That's what I picked this plant from. So are there any questions? Are any comments, concerns, any of all um, stories, anything? I'm open to hearing any of it.
Chi-miigwech, Johanna. Yeah, first I wanted to just say thank you for sharing that. And again, thank you for jumping in, and thank you for bringing in that good kind of stubbornness into the classroom. That's amazing. And just, breathing life into things that we know and making sure that, we can continue to learn about our foods and medicines that way. Okay, so then if you want to pull up that picture of the ribbon skirt, please do.
That is what I was studying for. Let's see here. It was in my slides for presentation because did I need a slide? No, which is why I took it out. But I put it in there because I wanted me in a ribbon skirt, and I couldn't present it I couldn't present it in person. I had to do it online behind a chair, but this was my ribbon skirt, and I was this like applique.
Wow.
I worked so hard on it because I wanted a ribbon skirt that reflected my project. So this is me presenting my project at State Fair. This is my poster from last year when I was doing this research, and I hadn't gotten into the lab at that point. So this is just all of that taxonomy review. But yeah, that was the first time I presented in my ribbon skirt. I feel like every ribbon skirt has to have that one moment where you break it in. You have to just get it out there. Gotta take it to powwow, which I haven't do because we haven't had powwow, and I'm sad about it. But it did get broken in a different way. So.
Okay, we do have a question. Well, first of all, some good comments. Fascinating. Thank you so much for this wonderful story. Someone's asking, is this also effective on heart conditions as the white lily? So I think, maybe so that person had heard that the white lily is good for heart conditions and maybe wondering if you have any thoughts. Plus, I think there's an elder cousin of yours, Johanna, on here that might have some info too, but I don't know if he feels like talking.
Yeah, I don't think that it does have the same heart properties. I know that it has been used in like those septic shock studies. Like they were starting to touch on it in some universities. I think that a lot of one of the questions I got in my science fair when I was presenting it for fair was something like that, and they asked me like, are there any other medicines that Indigenous people have from this area? And I thought they were kidding. I'm not gonna lie, I thought it was a joke, and I almost started laughing, and then I looked at their face and I was like, oh, you're not kidding. So I don't think it is, but it's possible because I don't think that books have done an amazing job at recording all of our stories of medicines, but it's quite possible, being as it is a water plant, just not the same. And it is in the same genus, so it's in the Nymphaea genus versus the Nuphar genus. And the Nuphar genus just means it has a yellow flower versus a white flower, but it has the same similar family ties when they did the genetic research.
And I don't think I'm seeing any other questions in the chat, just a lot of gratitude. And we do have a good 15 minutes left too. So if people want to chime in with questions, they can feel free to just unmute and ask them, or if they have stories they want to share, then we definitely have time. Okay, one comment. Oh, you seen that? Okay.
Yeah, I looked through it too. That's one of the questions I actually had because of how much it sucks out. So when I tested it in the lab, it tested only because of what properties it harbors. There's a whole nother aspect to it. So when you dry, bacteria likes cold, warm, not cold, take two, likes warm, dark, wet environments. You can eat it, and I ate it. Would not recommend. Like if I was starving to death, maybe, but mm-mm. And it like completely dries your tongue out. So when it's dry too, it also wicks up a lot of moisture. So it's kind of a twofold. When we put it into wounds, not only did it kill bacteria, but it also stopped the bacterias from growing, the bad bacterias from growing at all, because it got rid of all that moisture that gives it an opportunity to grow. So it created an inhospitable environment along with killing the bacteria that was causing harm. So that's something that was really interesting that I found out while I was talking to a microbiologist at UMD, and she was really awesome. Her name is Dr. Sieber, and I'm not gonna lie, I've had so many issues with my project with other teachers where they've been like, I don't see why you want to keep including the story in this. Like it's not as important as the science. And that's kind of where that bullheadedness, as my grandma says, just keep coming out. And she came to my award ceremony Sunday. She came to my award ceremony for science fair, and I got second place overall out of the entire science fair, which means I got sent to an international science fair program. I got nominated for 3 of them, but this one I get sent to. I don't have to apply. I don't have to do anything. Like I'm there. Tickets in the mail. Like it's good to go. So she was there, and the first thing I was freaking out, and the first thing she said was, "See, your stubbornness paid off." So I guess that we can all remember our bullheadedness pays off at the same time.
And someone asked how you got interested in science.
I don't know. I feel like science and math, which it doesn't go over with my friends either, but science and math are my favorite subjects in school. I love them a lot. My mom used to be a math teacher, and my grandpa was a whiz at math. He was an odd job farmer, but he was a whiz at math. And my whole life I was told like math and science, you use them for everything. Don't cut corners in math and science. You can use it in everything. English, nah. So I later earned an auntie from a roundabout way. She was friends with my mom before I was born, and she's an English professor, and she doesn't appreciate this story. But English is not quite as important, but math and science, you need those ones. So I feel like it was kind of family instilled, and then after that I just kind of got sucked into it. I couldn't stop.
Yeah, and someone mentioned, just for the group and for the recording, a good book. If you're looking at plant knowledge, plants have so much to give us. All we have to do is ask. Anishinaabe Botanical Teachings by Mary Genius. I don't know if I'm pronouncing that right, but yeah, that's definitely one in my library, and it's a good place to start.
I don't think you can see it, but behind me is a bookshelf, and 2 shelves of that bookshelf is all ethnobotany books. And when somebody asked me, I did a presentation about how Eurocentric or European viewpoints can taint the field of science, and how they focus only on what they've been instilled from England, from the Eurasian continent, from the advanced societies, and how that really affects things. And that was really reflected in that taxonomy review that I did, about how they immediately thought that it was going to relate to what they had in England, and it ended up being that our stories were right in the end. And had they had just listened at the beginning, we wouldn't have had to wait until 2017 to have documented science proving that we weren't full of crap, which is kind of what my project is all about. But I guess small baby steps.
Okay, any other questions, comments? I know I was definitely interested in hearing a little more about how you engage with elders during.
Yeah, it was a little tough. I sent a lot of things in the mail. I sent lots of virtual sema to ask my questions. I was like, I'm really sorry. I really wish I could ask you this in person and give you this gift, but for now, here's a picture of it and it's in the mail. But and that was tough. That was a lot of phone calls and stuff, and I missed the like, I call them the Yoda walks. I feel like everyone has that one elder where you ask them a question and their first answer is, let's go for a walk. And it's like, with Anakin, I'm like a big Star Wars and like science fiction nerd about all this kind of stuff. But when he asks Anakin, he's like, let's go for a walk. We'll talk about it. And he doesn't. He goes around the topic in a roundabout way. And Anakin finally loses his mind. And he's like, "Don't you just tell me already? Would you just get to the point?" I missed those. I missed having those nature walks and talking in a roundabout way and trying to like get to the heart of what they're trying to say. But I feel like I did the best I could in the scenario I can. I really wish I wouldn't have had to, but I had to protect everyone, but it didn't feel right. It didn't feel quite right.
Understandable. I've run into that a lot too. So a couple of questions in the chat. Do you plan on more research projects with different medicines? And then a similar question, do you have any more plants, herbs, or flowers lined up for your next projects? So yeah, what's next?
I think the first thing I'm going to do is finish those next questions. So about the heavy metals and what affects it. And then my life goal. I don't know if it'll be with this project, but my life goal is to be published in the Journal of Ethnopharmacy. And it's literally a book of people who have just gone through the work to prove Indigenous medicines. And that's my, if I could give anything, that's what I want. Like, I want to go to like a crazy cool college, of course, but I want to be in that. I want to be able to say, yeah, I did the work too. So that's kind of my final goal. But after that, I don't know. We'll see. We'll see what happens. Maybe I'll end up picking another plant and starting all over again. But for now, I think we're just gonna ride her out with what I got. And then the invasive species. Invasive species actually haven't had a documented effect on it. In fact, it's been the opposite. So a Nufard being a species, as climate change ramps up, it moves farther and farther south. Why? I don't know. You would think that it would go farther and farther north, because that's what makes sense, but nope, it went south. And in the southern lakes, how warm it is, it just takes off. It completely covers the entire lake. And so then that, if you actually look this up, its common name is called spatterdock, which is weird. I also found out that my family and the community I live in does not call things what U.S. government thinks is the common name, because that is just a yellow water lily, right? That's a yellow water flower. Not spatterdock, cow lily. I don't know. The list goes on and on. Nobody can agree on a name. But it's classified as a nuisance species, which means there's no consequences for pulling it up. So I know in like the state of Wisconsin, you're not supposed to pull up any water lily because it's a state offense and you can get in trouble, big trouble. And it's not the case. So the government literally pays for things to go out there and rip it all up, which I can understand. Like, it's taking over the whole lake, but then they just burn it. Like, they harvest all this medicine and then they just burn it. And that just gets me fired up. I could talk for ages about how you could recapture all of these things that we've classified as nuisance species that probably have documented use, but they don't. They just burn it and they get rid of it and they decompose it, but it just gets me riled up. So something that I'm hoping is another step in my project is to advocate for how can we recapture all this stuff that we're just ripping out anyway, especially if that heavy metals things doesn't shake out. Like, if it doesn't absorb heavy metals, if it does absorb heavy metals, probably not a good thing to use because we're putting it like straight into our bloodstream. But so then you'd have to do like lab grown stuff, but I don't know. That just isn't, it doesn't seem right to harvest your medicines from a lab. That's kind of what I'm trying to get away from, not like asking people to, yeah, let's go it in a pot. But if you got to do it to keep the plant alive, keep the medicine alive, it can make sense. But as of now, maybe not.
Okay, we're getting close to the end of class, so I was gonna maybe stop the recording if there's anything anyone wanted to add that they didn't want to be recorded. Is that okay with folks? I don't know if you want to do like thumbs up or little reaction, or maybe I'll just do it. But yeah, so I'll stop the recording and we'll just hang on for a couple more minutes if there's anything anyone wanted to say or share. So for the recording, miigwech again, Johanna, and thanks everyone for attending.